So the first thing we'll do this year is actually cover pretty much all of Chapter 1 in one quick lesson. Chapter 1 of the 6th grade math book goes over adding, subtracting, multiplying, dividing, estimating, all kinds of things with whole numbers, regular, good old-fashioned numbers, no decimals, no fractions. So we do this in my room pretty quickly, and then we'll slow down a bit and tackle decimals and fractions. So, first thing up is compare. Compare the two numbers using greater than and less than symbols. So we've got 37,999 being compared with 38,000. 38,000 is bigger, so we would draw in the less than symbol because 37,999 is less than 38,000. 473,365 comparing with 473,360. The first number is bigger, so we put the greater than symbol. And 4 trillion compared to 4 billion. 4 trillion is larger, so greater than symbol again. Write this number out using words. Okay, so we have our hundreds, our thousands, our millions, our billions. So this is 42 trillion to start with. So this is 42 trillion $358 billion 427,941,014. I have to stop. I don't have the space here to write this out on my iPad screen. But this is literally just writing everything out in words. Estimate. Estimate to the tens place. So instead of 385, to the tens place, that's 390. When estimating to the tens place, we will look at the number in the ones position, the unit position. It's 5. 5 tells me to round up. 215 to the nearest 10 is 220. Again, with a 5 in the ones position, I should round up. I'm adding those. So 0, 11, carry the 1, 610 when you round. Our next problem says estimate to the hundreds place. So our first number is 131. To the nearest hundred, that is 100. 309 to the nearest hundred is 300. We round both of these down. We start with 2 zeros. 3 times 0 is 0. 3 times 0 is 0. 3 times 1 is 3. This is 30,000 when estimated to the hundreds place. Because we rounded both numbers down, this is an underestimate. Underestimate means we went down instead of up. Next, we have some basic evaluation problems. So addition. We can just stack numbers up vertically to add them. Lining up by place value. 5 plus 3 is 8, plus 1 is 9, plus 4 is 13. Carry the 1. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 5 is 11, 11 plus 9 is 20. So that's 203. 432, 475, 1220, 989, 851. Again, we're adding so we can just stack these numbers up vertically, taking care to line them all up. 2 and 5 is 7, 7 and 9 is 16, 16 and 1 is 17. Draw the 1, carry the 7. 1 and 3 is 4, 4 and 7 is 11, 11 and 2 is 13, 13 and 8 is 21, 21 and 5 is 26. Carry the 2. 2 and 4 is 6, 6 and 4 is 10, 10 and 2 is 12, 12 and 9 is 21, 21 and 8 is 29, and 2 and 1 is 3. So when put all together, those 5 numbers add up to 3,967. Now we've got some larger numbers, but we do the same thing. 22,012, 33,043, and 471,209. We're adding still. 2 plus 3 is 5, 5 and 9 is 14, 1 and 1 is 2, and 4 is 6. 0, 0, 2 gives us a 2 in this column. 2 and 3 is 5, 5 and 1 is 6. Go ahead and put my comma in. 2 and 3 is 5, 5 and 7 is 12, carry my 1, 1 and 4 make 5. Subtraction, easy business. We're going to rewrite these vertically, so 319, 275, subtract. 9 minus 5 is 4. I have to borrow to be able to do this next one. 11 minus 7 is 4. 2 minus 2 is nothing, so the answer is 44. 471 minus 245, I have to borrow to do the first piece. 11 minus 5 is 6. 6 minus 4 is 2. 4 minus 2 is 2. 40,000 minus 35,625. I have to borrow from zeros, and I can't do that. So we have to borrow all the way at the beginning. We have to borrow from the 4, make that a 3, so our next number is 10. Borrow from 10, make it 9 to make the next digit 10. Borrow from 10, make it 9 to make 10. Borrow from 10, make it 9 to make 10. We have to borrow all the way through this so that we can do the very first term. 10 minus 5 now is 5. 9 minus 2 is 7. 9 minus 6 is 3. 9 minus 5 is 4. And 3 minus 3 is 0. And we don't put zeros in the beginning. So that's 4,375. Multiplying. 45 times 27. 7 times 5 is 35. Carry the 3. 7 times 4 is 28. 28 plus 3 is 31. Start with a 0 on the second line. 2 times 5 is 10. Carry the 1. Got rid of that 3 I used. 2 times 4 is 8. 8 plus 1 is 9. We're going to add these up now. 5 and 0 is 5. 1 and 0 is 1. 3 and 9 is 12. Put in my comma for 1,215. 38 times 29. 9 times 8 is 72. Carry the 7. 9 times 3 is 27. 27 plus 7 is 34. Get rid of that 7 because I used it. Start the second line with a 0. 2 times 8 is 16. Carry the 1. 2 times 3 is 6. 6 plus 1 is 7. Now add up my two lines. I got 2, 10, and carry the 1. And that makes the first column 11 when I add it up. Put in my comma. 50 times 60. Because the first digit is a 0, I can start with a 0. 6 times 0 is 0. 6 times 5 is 30. That's 3,000. 231 times 35. 5 times 1 is 5. 5 times 3 is 15. Carry the 1. 5 times 2 is 10. Plus 1 more is 11. Cross out my 1. Second line always starts with a 0. 3 times 1 is 3. 3 times 3 is 9. 3 times 2 is 6. Add these up now. 0 and 5 is 5. 3 and 5 is 8. 1 and 9 is 10, so carry a 1. 1 and 1 and 6 make 8. That's 8,085 when put all together. 341 times 81. Well, 1 times anything is itself, so the first row is 341. Start with a 0 on the second row. 8 times 1 is 8. 8 times 4 is 32. Carry the 3. 8 times 3 is 24. 24 and 3 is 27. Add these up now. 1 and 0 is 1. 4 and 8 is 12. Carry the 1. 1, 2, 3, 4, 5, 6 in this column. And the 2 and the 7 don't have anything to actually combine with, so they just stay 2 and 7. 258 times 57 now. 7 times 8 is 56, carry our 5. 7 times 5 is 35, plus 5 is 40, carry the 4. 7 times 2 is 14, plus 4 is 18. Cross out the 4 and the 5 that I used. Start with a 0. 5 times 8 is 40, carry a 4. 5 times 5 is 25, 25 plus 4 is 29, carry a 2. 5 times 2 is 10, 10 plus 2 is 12. Add now, we're going to have 6, 0, 17, carry the 1, 4, 1, to make 14,706. 3 by 3 multiplication, no big deal. We've got 311 times 448. 8 times 1 is 8, 8 times 1 is 8, 8 times 3 is 24. I'm not giving myself enough room to do this here. Let me I might be able to squeeze it in now. 4 times 1 is 4, 4 times 1 is 4, 4 times 3 is 12. Start third line with 2 zeros. 4 times 1 is 4, 4 times 1 is 4, and then we have a 12. I can't write my plus sign in, but we are going to add these up now. 800 is 8. 840 is 12, carry the 1. 3 fours is 12, with the 1 more is 13, carry a 1. 1 and 2 is 5, and 4 is 9. 1 and 2 is 3, and 1 is 1. This is 139,328. 794 divided by 4. 4 goes into 7 one time. We will subtract 4. That's 3. Drop the 9 down. Neatness is important when you divide. 4 goes into 39 9 times. That's 36. We subtract. 39 minus 36 is 3. Drop the 4 down. 4 goes into 34 8 times. That is 32. So we have a remainder of 2. Don't get used to having remainders. You're allowed to have them for chapter 1 and for one section in chapter 2 when we divide. After that, remainders will be a thing of the past. Next up, we have 2,612 divided by 9. And I'm actually going to do this with a shortcut. So 9 does not go into 2. 9 goes into 26 twice. So I put that 2 over the 6 from 26 after the last digit. Goes into 26 twice with a remainder of 8. The next number is 27. 9 goes into 27 perfectly, so there's a remainder of 8. So I can actually write that remainder right there. I can use this shortcut method with small digits like 1 through 9 when I know my times tables and my addition and subtraction pretty well. If you don't, do it long form like I did number 20. 9 goes into 81 9 times, and that's 81 perfectly, so there's no remainder. And 9 does not go into 2, so we have to put 0 here. But there's still that 2 left over, so it is remainder 2. I'm going to do this one by the shortcut again, because 7 is a single-digit number. And dividing by single-digit numbers allow me to use my shortcut here. So 7 goes into 25 3 times. That's 21. So we're talking about a remainder of 4. 7 goes into 41 1, 2, 3, 4, 5 times. That's 35. The difference between 41 and 35 is 6. 7 goes into 61 8 times. That's 56. So 56 to 61 is a remainder of 5. And 7 goes into 58 8 times. That's 56 with a remainder of 2. just so you can see it, I'll work it out properly. 7 goes into 25 3 times. That's 21. When I subtract, I get a 4 and drop the first one. 7 goes into 41 5 times. 5 times 7 is 35. When I subtract those, I get 6. Drop the second one. 7 goes into 61 8 times. That's 56. When I subtract that, I get 5. Drop the 8. 7 goes into 58 8 times. That's 56. 58 minus 56 is a remainder of 2. 689 divided by 10 now. 10 goes into 68 6 times. That is 60. 68 minus 60 is 8. Drop the 9. 10 goes into 89 8 times. That's 80. So it is 68, remainder 9. And last, for division, I think, 1,125 divided by 25. Well, 25 doesn't go into 1 or 11, but it does go into 112 4 times. Because 4 times 25 is 100. When I subtract these, 112 minus 100 is 12. Drop down the 5. 25 goes into 125 5 times perfectly. When I subtract those, I have no remainder. Exponents. So you have to remember what an exponent is. Hopefully you've seen them before. If not, you're about to learn something new very quickly. 3 to the 4th power means we have 4 3s being multiplied. Now, multiplication is something called commutative, meaning I can do it in any order I want. So I can combine the first 2 3s into a 9, the last 2 3s into a 9, and leave multiplication in between them. And then, of course, 9 times 9 is 81. Seven to the 3rd power. I'm actually going to do that down here. That's 7 times 7 times 7. 7 times 7 is 49. We should know that. Now 49 times 7, I don't know off the top of my head. So I'm going to squeeze over to the side here and do that. 7 times 9 is 63. Carry 6. 7 times 4 is 28. Plus 6 is 3 and 4. So when I multiply these together, I get 343. Up next, we have 13 to the 5th power. So that's 13 times 13 times 13 times 13 times 13. That's a lot of 13s. 13 times 13, luckily, is 169. Hopefully, some of you know that as a perfect square. Now, we're stuck doing this the hard way. 169 times 169. And there's no real short way of doing this. 9 times 9 is 81, carrying 8. 9 times 6 is 54, with 8 more is 62, carry a 6. 9 times 1 is 9, plus 6 is 15. Start with a 0. 6 times 9 is 54, carry the 5. 6 times 6 is 36, with 5 more is 41, carry a 4. 6 times 1 is 6, plus 4 is 10. Get rid of the 4 and the 5. Start with 2 zeros, and now 1 times 169 is 169. When we add, we get 1, 6, 15, so carry a 1. 1 and 6 is 8, and 1 and 1 is 2. We've got 28,561. That was the two 169s. I still have this 13. So I have to take that times 13 to get my final answer. You have to scroll this down a little bit so I've got room to do it. 3 times 1 is 3. 3 times 6 is 18. Carry a 1. 3 times 5 is 15. With 1 is 16. Carry the 1. 3 times 8 is 24, with 1 is 25, carry a 2. 3 times 2 is 6, plus 2 is 8. Cross off all the things that I carried. Start the second line with a 0. Hey, it's 1. 1 times anything is the thing. So I can go 1, 6, 5, 8, 2. And then we just have to add. So 3, 9, 12 carry the 1, 11 carry the 1, 17 carry the 1, and 1 and 2 is 3. So 13 to the 5th power is 371,293. And 4 to the 9th. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 fours. Well, let's shorten this up a little bit. The 4 times 4s that I can pair off are 16s. And luckily, I know that 16 times 16 is 256. You may not yet. It's a good thing to memorize your perfect squares up to 25 times 25. So 4 times 4 times 4 times 4 is 256. So now if I do 256 times 256 times this last 4 out here, we can find out what 4 to the 9th power is. So this is just some time-consuming multiplication. 6 times 6 is 36, carry a 3. 6 times 5 is 30, with 3 more is 33, carry another 3. 6 times 2 is 12, with 3 is 15. Start with a 0. 5 times 6 is 30, carry a 3. 5 times 5 is 25, with 3 more is 28, carry a 2. 5 times 2 is 10, with 2 more is 12. Start with 2 zeros and get rid of what I multiplied by. 2 times 6 is 12, carry a 1. 2 times 5 is 10, with 1 more is 11, carry a 1. 2 times 2 is 4, with 1 is 5. Add these all up now. I get 6, 3, 15, so I have to carry a 1. 1, 2, 3, 4, 5, and 6 here. So we're at 65,536. And I'm just going to double check that real fast. I am correct. So that's 256 times 256. We just have that 9th 4 to deal with. 4 times 6 is 24. Sorry, I lost my train of thought for a second. 4 times 3 is 12, plus 2 is 14, carry the 1. 4 times 5 is 20, plus 1 is 21, carry the 2. 4 times 5 is 20, plus 2 is 22, carry the 2. 4 times 6 is 24, plus 2 is 26. So we're talking 262,144. Writing in exponent form now. There are 1, 2, 3, 4s, so this is 4 to the 4th power. There are 1, 2, 3, 4, 5, 6 5s, so this is 5 to the 6th power. And there are 1, 2, 3, 4, 5, 6, 7 7s, so that's 7 to the 7th power. That's all we're asked to do, write it in exponent form. We're not being asked to evaluate. And I do believe almost last except for some matching, order of operations. PEMDAS. There are no parentheses in this example. There is an exponent, 3 to the 3rd power. 3 to the 3rd power means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So that first number is actually 27. That's the exponent. There is multiplication here. So we're going to have 27 minus 2 times 4 is 8, plus 7. And now that I'm down to subtraction and addition, I actually just do those in order from left to right. 27 minus 8 is 19. 19 plus 7 is 26. There are parentheses in this problem. So the first thing I have to do is what's inside of them. 6 minus 2 is 4. Now there's an exponent in this term, 2 to the 4th, so I evaluate that next. 2 to the 4th means 2 times 2 times 2 times 2, so that's going to be 4 times 4, and that's 16. Next we will multiply, so 4 times 8 is 32. And now, since this is addition and subtraction, I'll just work left to right. 16 plus 32 is 48. 48 take away 5 is 43. Parentheses first. 4 minus 2 is 2. Exponent second. We've already done 3 to the 3rd power before, it's 27. Now, there's division and multiplication. I just do those in order from left to right. So 18 divided by 9 is 2. 27 times 2 is 54. And now when I add these, I'm looking at 56. Parentheses first. So we copy everything else down. 4 times 3 is 12. Exponent second, parentheses, then exponents. Then multiplication or division from left to right. So it's going to be multiplication because multiplication comes first here. 41 times 2 is 82. Then we will do the division. 36 divided by 12 is 3. And now this is just a bunch of addition. So we could actually just stack these up vertically if we wanted. I'm just going to go ahead and go through and do it piece by piece. So the first two combine to make 109. Then we would have, not 10, sorry. Then we would have 112 when we combined. And then we would have 161 in the end. And last up, some vocabulary with matching. These are various properties. So this first thing shows me that I can add in any order. That is the commutative property, C. The next problem shows me that if I multiply by 0, I get 0. That is the 0 property of multiplication. 1 times 17 is 17. I've done an operation on 17 but not changed it. When I can do an operation and not change the number, that is called an identity. The multiplicative identity is 1. If I multiply by 1, it doesn't change anything. If I am adding, the additive identity is not 1 because adding 1 changes the value. Adding 0 doesn't change the value. So number 40, if you jump ahead for a second, is also an identity problem. Number 39 shows me that if I have 3 plus 2 plus 6, that is the same as 3 plus 2 plus 6. It's showing me that if I have all addition and I can move parentheses around. The ability to move parentheses around is called the associative property. Number 41 is showing me if I have 6 times 2 plus 4, it's the same as 6 times 2 plus 6 times 4. I have given the 6 to both 2 and 4. That's called distribution. Giving one thing to multiple other things is distributing it. It's giving the 6 to everybody. In number 42, we have parentheses moving around again. That's 6 times 4 times 3, being the same as 6 times 4 times 3. That is another example of the associative property. It is true for multiplication as well as addition. And last, we have 32 times 13 being the same as 13 times 32. That is multiplication being done in any order. Being allowed to change the order of things is the commutative property, which is C.